Hi, Year 10. This is our fourth lesson for the topic of equations for the new New South Wales curriculum, and this is the advanced pathway. In this lesson, we're going to look at the discriminant. So this is what we've covered: linear equations and literal equations. And then last lesson, we looked at quadratic equations, including factorizing and the null factor law, completing the square and the quadratic formula, word problems and formulae, equations reducible to quadratics, and forming a quadratic equation. Now, when we solve ax squared plus bx plus c is equal to 0, we are finding the x values that make the equation equal to 0. And these are called zeros or roots of the equation. And graphically, they are the x-intercepts of the graph. They cut through or touch the x-axis. Now, we talked about the fact that a quadratic equation can have 0, 1, or 2 solutions. And graphically, this is what it looks like. This one here has 2 solutions. It cuts through the x-axis here and here. This one only has 1 solution. It just touches the x-axis. And this one doesn't have any solutions. It never touches or cuts through the x-axis. Now let's look at some examples, and we're just going to use the quadratic formula. So with this first one, a is 1, b is -5, and c is 3. And substituting in, we end up with this. And when I tidy it up, we have 5 plus or minus the square root of 13 all over 2. So there are 2 solutions. Now in this case, when we substitute in, we get a 0 under this square root, which wipes out that plus or minus. So we only end up with 1 solution. And finally this one, when I substitute in, I end up with a negative under the square root, which means that I have no real solutions. Now that's a rather long and quite unnecessary method for working out whether a quadratic equation has 0, 1, or 2 solutions. There's a much easier way. All we have to do is calculate the part that's underneath the square root, and that's going to tell us. Now this part is called the discriminant, and it has the symbol delta. So let's look at those examples again, and this time we're just going to look at the number that's under the square root. So in this first case we have 13, and that tells us that there are going to be 2 solutions. Here we have 0. Remember I said that wipes out the plus or minus, and it means we only have 1 solution. And here we have a negative under the square root, and that tells us that there are going to be no solutions. So here's the rule. If our discriminant is less than 0, so negative, we get a negative under the square root, which means we have no solutions. If it's equal to 0, it wipes out the plus minus, which means we have only 1 solution. And if it's greater than 0, then we have 2 solutions. So let's use the discriminant to find the number of solutions to the following quadratic equations. Now it's really easy. We just have to work out b squared minus 4ac. And remember, a is 2, b is -1, c is 9. So in this case, our discriminant is -1 all squared, take away 4 times 2 times 9. It's negative. Do you remember what that means? No solutions, because we can't do the square root of a negative number. Let's do it again with this one. Our discriminant is -5 all squared, take away 4 times 1 times -11, 69. There's no problem with doing the square root of 69, and that's going to give us 2 solutions. With C, our discriminant is equal to 0. This wipes out the plus minus, so I end up with only 1 solution. And the last question, we end up with a positive again. No problem with square root of 84, we're going to have 2 solutions. Now there is one other piece of information that we can get from the discriminant. We can tell whether a quadratic equation can be factorized or not. Let's have a look at these 3 examples. Here's the first one. The discriminant is 49, so we have 2 solutions. In this case, the discriminant is 61, still got 2 solutions. And finally, we have the discriminant is 25 and 2 solutions. Now, 2 of these can be factorized. And the clue is, are they a perfect square or not? Because remember, this goes under the square root sign. So in this case, I can do the square root of 49, which is 7. Here, I can do the square root of 25, which is 5. But here, square root of 61, that's irrational. So this one can't be factorized. So let's just add that to our diagram. So our discriminant, less than 0, no solutions. Equal to 0, 1 solution. Greater than 0, 2 solutions. And then if it is a perfect square, those solutions will be rational. Remember, rational numbers can be written as fractions. And if it's not a perfect square, then they will be irrational. They'll be surds. Let's finish off with these examples. Describe the roots of the following quadratic equations. So working out the discriminant, we end up with 53. So there's two real roots. But 53 is not a perfect square, so the answers will involve surds. They're going to be irrational roots. This one, the discriminant is negative. That's easy, isn't it? There's no real solutions. Now in this case, what's happening here? There's no term in x, so b is equal to 0. Our discriminant is going to be 0 squared. Take away 4 times a times c. And that's equal to 144, which is a perfect square. So there are two solutions, and they're both rational. And then finally this one, the discriminant is equal to 0, which means we wipe out the plus minus term and the square root. So there's one solution here, and because there's no square root, it also has to be rational. Okay, so that's it. Our next lesson and our final lesson in this topic is simultaneous equations.